As you might have seen, I'm going to talk about SugarCane. In short, SugarCane is a set of mappings that uses the same data as Parchment. So it uses the Parchment data, but it removes the P prefix on Forge. So if you are not using Forge, you're probably not that familiar with that prefix and why that is anyway, but I think that even if you're not using Forge and not planning to use Forge, you can get some value out of this talk, as I am going to cover transformations on source code that keep it compilable. In this case, in a very specific example, but I guess it could also be taken further to a step where you have a tool that automatically updates mod source code for a new Minecraft version and reduce the effort of porting. So that for the start now, how do I use this thing? Oh yeah. Oh yeah. Seems to work. To have everyone on the same page, I'll briefly answer the question, what actually are mappings? I guess most of you will know, but maybe someone is here who just needs a little bit of refreshment. As we see here, the game as distributed by Mojang is obfuscated, and code looks like this a.b is equal to c.ab, which is not readable and also not compilable if you decompile that code, because like fields can conflict with class names, and the Java compiler can't determine if you meant a field or a class, so it will just fail. And that's why we need mappings. Mappings are like basically a big lookup table that map these unreadable names to something more meaningful. And yeah, we have a lot of different types of mappings for different purposes. Here are three of them that are relevant for SugarCane. First, we have the SRG mappings, which is short for Serge Retrograde. It is a stable mapping, just like intermediary on Fabric. So that means it keeps the same name for an element between different versions of Minecraft. It also is a unique mapping, which is very important for us. That means every field, method, or parameter gets a name that is unique across the whole Minecraft codebase. But the names are still not meaningful and not useful for actually writing mods. So that's why we need some more mappings. In our case, those are the official mappings, which are also called MojMap. These are the actual names that Mojang uses to develop Minecraft Java Edition. And since Minecraft version 1.14, I think they distribute them, so modders can use them. However, there's a catch. The official mappings only include classes, fields, and methods, and are missing parameters and Javadoc. To solve this, there is the Parchment project, which adds parameters and Javadocs on top of MojMap to get like mappings for everything, and those are mapped out by the community. Everyone can contribute there. Now, it looks like Parchment is everything you need, right? But if we actually start using Parchment and Forge, we notice a few inconveniences, which is first that every parameter is prefixed with a P, like we have here P-level and P-state. We'll get into why that is in a minute, but we can notice that the P prefix is pretty annoying because parameters are actually looked at very often, especially in code completion, contrary to local variables that you only see if you jump to the definition, but those don't have a P prefix, so the other way around could be better. And another point you notice when using Parchment and Forge is that lambda parameters keep their SRG names and are not mapped at all. So that sets up our goals for SugarCane, which are two. There are two of them. One is remove the P prefix, at least where it is possible, and the other one is get parameter mappings for lambda parameters. So now in order to understand how SugarCane works, we need to look at why the P prefix is there in the first place. And that all boils down onto the way Minecraft Forge sets up their game and applies its changes. So what we have here is the graph that describes this process. You should note that it is simplified and skips over some steps that are not relevant here. But yeah, in the first step, the server and client jar are merged together to get one single jar with the code for both, which is then further processed. In the second step, the obfuscated names we saw earlier are remapped to SRG, which makes the code actually compilable, which is why step after is the decompile step, where the ForgeFlow decompiler will create source code from the game. Then comes the patch step, which adds the Forge changes to the Minecraft code, like firing events and such. And then in the final step, the code is recompiled again to have bytecode patched by Forge. Now this process, as it is here, as I just described it, doesn't include any mappings with parameters, but we want them to be in the source code, so we need to inject the parameter data somewhere in here. The first thing you'll notice is the green part here. This is the part in the process where we are working on source code, and as we want mapped source code, we need to do it somewhere in that part. And the other thing you'll notice is that here we have the patch step, which applies patch files to the code, so which means it relies on the fact that the code that exists before it is always the same. So adding something in before would change the code and the patches would fail to apply. That's why it can't be done there and has to be at this point that we see here. Now, what is going to be important later is that, as I noted earlier, SRG is a unique mapping, so every name exists only once. And Forge uses that in this step between patch and recompile, which it makes mapping the source code much easier, because Forge can just do a regular expression replacement, replacing all the SRG names with map names. Now let's look at an example. Here we have a method that is from fishinghook.java, and you can see that method has no parameter names at the moment and uses the SRG name. So now the Parchment, that one parameter we see here, has a name in Parchment, which is entity. So if we now try to rename that, I do it here. So now if we rename that parameter to entity, you'll see that we have a compile error, because the parameter is now named entity and the local variable inside the method as well. This is invalid. To solve this problem, Parchment uses a very simple approach, which is like adding a p to every parameter. That's where it comes from. SugarCane will do the same in those cases where it does produce a compile error, but in most cases it will just work without. So SugarCane needs to somehow detect how where we can leave off the p and where we need to add it. So now we're getting into how that stuff actually works. First of all, building SugarCane needs the patched source code and bytecode with the official names, but no Parchment data available. Those can just be generated by Forge Gradle. The same process that happens when you set up a development environment on your own mod. And but instead of using the source code to look at it, SugarCane will use it and process it further. And then there's the source transform tool, which is the actual tool responsible for building the SugarCane mappings. And there are multiple steps, which we're going to look at now. The first step is the inheritance map, which is extracted from the bytecode. It's a large text file, and originally it just contained the class hierarchy of every Minecraft class to object. But later on, for different things that I wanted to do with it, it got more data, but that's why it is called inheritance map, which is no longer really describes what it is. But yeah, most important for SugarCane are the lambda mappings. We'll also get into what they are at a later point. But yeah, you can just take that inheritance map as an auxiliary file that is needed for the later steps. So now we have the step 2, which is actually processing the source code. For this, SugarCane uses the Eclipse Java development tools, which can parse Java source code into an abstract syntax tree. And then SugarCane will visit the whole AST of all of Minecraft's classes and take every method and look at what names are used as local variables or field access without a this. And then every method will get a parameter renamer. We have 3 types of them. There's always, which is just always renaming the parameters, just like Parchment does. It's mainly used as a fallback if SugarCane fails to find a parameter renamer, but there is a method reference in the Parchment data. Then there's keep, which will never rename any parameters. Sounds odd at first, but it is useful for lambda parameters inside field initializers where you have no method that encloses them. And then there's default, which is the most frequent one. Default comes with a list of names that are not allowed for parameters, and then it is going to rename only those parameters that are on that list. Again, we can look at an example here. Here we have a method. This is taken from the render system class, and you will see here at the bottom, you'll see which parameter renamer SugarCane uses for this method. And you can see those 4 values which end up here. The first one is the SRG parameter. This one is required for multi-parameter methods. Suppose you have a method with 2 parameters and rename the first parameter to the same name as the second. This would fail, so this name is not allowed. Then we also have the local variable name matrix4f here, which is due to the thing that we saw before, where it conflicted with a local variable. Also here we have a static field called texture matrix that is accessed without any prefix. So naming the parameter texture matrix would shadow the field, and that field access would go to the parameter instead. And we have the class matrix for f. If we renamed the parameter to this uppercase matrix for f, it would also fail because the declaration of the type of the local variable would then reference a parameter, and Java would complain. So in the final step, SugarCane will take the Parchment data and then process it. So it goes over every parameter mapping, takes the parameter renamer for the method that parameter is used in, and then changes the name if required. Here we can see an excerpt. We have the raw data on the left, and then we have the SugarCane data on the right, and you can see that the potion parameter was renamed to p potion because it would conflict otherwise. Now, yeah, that is the basic idea how it works, but it's not that easy. Source code is complicated, and in a Minecraft environment where you work on decompiled code that has been remapped twice, it makes stuff only worse. So, of course, we have some special cases that need some special attention in order for SugarCane to actually work. The first case I want to cover is SRG uniqueness. So now remember when I said that SRG names are unique across the whole code base. This is only partially true, because if you have Torch patches, they can duplicate the SRG names. So in the vanilla code, every SRG name is only used once, but here we have an excerpt from Forge. It's from the advancement builder class. And the top method is the vanilla method with those two parameters and their SRG names. And Forge patches in the bottom method here, which adds a third parameter and is patched in by Forge. But you'll notice that the first two parameters share the same SRG names. Now, the Parchment data only knows about the first method here, so it just won't cover the second one. And now if we try to rename the parameters as the Parchment data says, we'll get this. As you can see, it works in the first method and needs no p prefix there. There's no compile error. But now, because the source code is remapped via a regular expression, as I said before, it has also renamed the parameters of the second method. And now we have two parameters named context, which is obviously a compile error. So we need to do something against this. But the solution here is pretty easy. SugarCane will just check for every parameter being in a SRG parameter, and then it will merge the renamers of methods that have common SRG parameters. So the renamer of either of those methods will make parameters that work with both of them. And that's why SugarCane will then actually add a p prefix to the second parameter here and also in the top method, and thus can prevent the compile error. Now there is another problem, which is the local classes or anonymous classes as well. Because in those classes, they can declare fields or inherit fields from a superclass. And then if you reference a name inside the class, it will try to find a field first before a parameter from the outer method. And this way, a field name can shadow a parameter name, and it's then impossible to reference the parameter at all. We have an example here with 2 or 3 classes if you count the local one. And you can see that the local class extends the message printer, which in turn has a field named message. And there's also a parameter named message on the makePrint method. And the bold message here that is printed actually refers to the field of the message printer class, and it's not possible to reference the parameter from that point. To solve this, SugarCane will check when a parameter is used inside a local class, and in that case it will also add a p to every parameter that is used inside a local class to prevent those kinds of errors. Actually, Parchment does validation on their data before they publish it. That is supposed to catch this, but it just currently doesn't work, so SugarCane has to do it. And then we have our second goal, and by far the most complicated special case, which are lambdas. The key problem with lambdas is that they are defined on bytecode names. And so to understand that, we have to look at how lambdas actually work in the bytecode. So suppose we have a class with 3 lambdas that you can see at the top. And then we run this class to the Java compiler. Then we'll get a class file with 2 methods. named lambda $static $1 and lambda $is valid $0, where static and is valid are the methods in which those lambdas were used. And those methods actually contain the code that you can find inside the lambdas. If Parchment maps a lambda parameter, it adds it as a mapping to those implementation methods that are generated by the compiler. Now what we can also see here is that we have no one-to-one relationship between lambdas and the implementation methods, because the last two lambdas are actually doing the same thing, and so they share the same implementation method. Makes class files smaller if you have a lot of the same lambdas, but makes SugarCane's life harder. So now when processing the source code, SugarCane only sees the source code versions of the lambdas, and it's not possible for SugarCane to find these relationships between lambdas and implementation methods on its own. But what SugarCane can do, it's, as I said, SugarCane uses the Eclipse Java development tools, and they come with a compiler, the Eclipse Java compiler, and that compiler generates internal lambda IDs that you can get with a bit of reflection. And this way the compiler assigns the same ID to the to lambdas with the same implementation who would share an implementation method in the bytecode. And now here comes the inheritance map, because the inheritance map contains mappings from those internal lambda IDs of the Eclipse Java compiler to actual implementation methods. And this way SugarCane can map the actual lambdas to the implementation method. Well, it mostly can, but again, Forge patches make things worse. Like imagine Forge patched a new lambda into the source code at the very beginning. Now you will notice the ideas given by the Eclipse Java compiler also use running index, and so they are all off by 1 now. So when SugarCane tries to resolve the lambdas to the implementation methods, and Forge added a lambda somewhere, it can sometimes resolve them wrong.
Is someone being mugged out there?
Anyway, yeah. So to prevent this, as you can see in those names of the implementation methods between the two $signs, it has the name of the method where the lambda originated from, and SugarCane uses that to check whether a relationship can actually be valid. So, like here, if if this lambda, the o.forge method lambda, resolves to lambda.isValid.0 but is not used inside a method named isValid, SugarCane will drop that lambda and not process it any further, prevent those kinds of issues. That check isn't perfect, but it is good enough to not, at least it hasn't caused troubles yet, and well, if it does in the future, maybe there will be a better system, whatever. So now that we have a relation between lambdas and implementation methods, renaming the lambda parameters actually gets pretty easy. Because whenever SugarCane finds an implementation method in the Parchment data, it can just look at which lambdas use that implementation method, and then take all the methods that contain those lambdas and merge their parameter renamers together, and then use that parameter renamer on the lambda parameters to also map them, and only add a p if required. Yeah, that's a little bit wrong on the slide. I looked that up, and actually conflicting lambda parameters get a p and are not discarded. Yeah, so before we getting to an end, I should probably also tell you a little bit about how you can actually use SugarCane. SugarCane is built for every Parchment release, but we do not build SugarCane for snapshots or nightlies because it takes a while and uses disk space and such. But yeah, you get a SugarCane version for every Parchment release. And you can use it using the mod Gradle plugin, which adds a mapping channel named SugarCane that can be used the exact same way as the Parchment channel, but will load the SugarCane mappings. For more information or a more detailed description on how to use SugarCane, you can visit moddingx.org/sugarcane. There you'll also find a written version of what I just told you if you want to read something. Otherwise, if you're trying to use SugarCane or you're stuck or you have idea for improvements, here's a Discord where you can get help or talk about SugarCane. And yeah, that's it. I got a question while I was talking. So we have when a parameter conflicts with a variable, why not name it like entity1 and entity2? The P feels like it, well, yeah, no, I can't read that. I'm not sure what exactly you mean. If you mean renaming the parameter entity1 or entity2, that could be done, but yeah, SugarCane just uses a P. It would not be much effort to change it to any other kind of parameter sanitization. But yeah, if you meant renaming the local variable to entity1 and 2 and keep the name on the parameter, that's not possible because the decompiler chooses the names of the local variables before the toolchain actually knows about the parameter mappings, so they are set in stone once the parameters are mapped. Are there any more questions? Yeah, modding X, I've seen that in chat. Yeah, it's basically me and Melon, who's in the audience there. Yeah, and besides SugarCane, we also we have a lot of tools, mainly tools for making modders' lives easier. There's like also HackDev, which got an overhaul lately. It allows you to make mod packs with Gradle and then build a CurseForge mod print, multi-MC, and like server pack from the same source and stuff like that. Maybe. Then, if there are no more questions, I guess that's it. Yeah.